Good morning, awesome Algebra 1 students, and welcome to today's math lesson. In today's lesson, we are going to be reviewing the properties of exponents that we learned in the last lesson, and we're going to be introducing something called a negative exponent, which does something very specific to the base. So in our warm-up for this video, what you're going to need is a piece of paper, and you're going to take that piece of paper and you're going to divide it into 4 quadrants, just like this. Now, what you're going to do is we're going to do a problem in each quadrant. So go ahead and number each quadrant 1 through 4. So we can start over here, 1, 2, and the order doesn't really matter, 3, 4. Now, what I'm going to do is we're going to talk about the same 4 properties of exponents that we learned in the last video. Product of powers, quotient of powers, power of powers. But this time, I'm going to bring in some negative exponents. And for now, we're not going to do anything with the negative exponents. We're just going to apply the rule as if the negative exponent wasn't even there. So let me show you what I mean. So for our first example, for our first warm-up problem, here's what we're going to do. We're going to do x to the 4th times x to the negative 6. Now again, the negative might freak you out, but what we're going to do here is we're just going to apply the property that it is. So I'm going to write out all 4, so you'll have a chance to do them on your own first, and then we'll go back and go through them. So number 1, x to the 4th times x to the negative 6. Number 2, x to the negative 2nd to the 5th power. Okay, x to the negative 2nd to the 5th power. Again, don't get freaked out by the negative. You'll be just fine. Number 3, we're going to do 2 kind of similar looking examples. X to the 7th divided by x to the negative 3rd. And then over here, I'm going to combine some. So number 4 is going to kind of be our challenge problem. We're going to go x to the negative 3rd times x to the negative 4th divided by x to the 5th. Okay, so this is going to be kind of our challenge problem going forward. So if you would like to try these on your own first, go ahead and pause the video now. And if you're looking like, no way, I can't do this on my own, then here we go. So the first thing that we're going to do is we're going to identify which of the 4 properties are we looking at here? Is it a product of powers, a quotient of powers, or a power of powers? Based on that property, it will teach us what we can actually do, what the quote shortcut is that we can do with the exponents. So number 1, is this a product, a quotient, or a power? Well, I see multiplication sign right there, which leads me to know that this is a product of powers. Now, in a product of powers, here is the quote rule or property. You're basically just continuing the multiplication, which means you're adding additional factors of x. So what's the rule for the exponents? We add them together. So here, I'm going to do this in 2 steps, and then I'm going to leave my answer looking a little bit weird, and you'll see why later on. So basically, because I have the same base, I have x and x, I'm just going to add the exponents 4 and negative 6. So essentially, it's x to the 4 plus negative 6, which adding a negative, by the way, is equivalent to just subtracting. So instead of writing this as plus negative 6, we could write it as 4 minus 6. And that just might make your math a little bit easier to do, but it's completely up to you, okay? What is 4 minus 6? 4 minus 6 is negative 2. So right now, we're going to leave our answer as x to the negative 2. So again, how did we get negative 2? We added 4 and negative 6. Why did we add? Because this is a product of powers, and in a product of powers, the rule says you add the exponents. And hopefully you're looking at that going like, I don't like that negative there. It makes me uncomfortable. We'll do something with that negative at the end of this video once we learn more about negative exponents. Let's move on to number 2. So number 2, is this a product of powers, a quotient of powers, or a power of powers? Well, I see a base that's a power raised to an additional power. So that tells me this is a power of powers. What's the rule in power of powers? Well, if you remember, this basically means that I'm multiplying x to the negative 2 by itself 5 times. Or in other words, I'm looking at 5 groups of this x to the negative 2. So the rule here is we multiply these exponents. So I'm going to show it again in 2 steps. So we have x to the negative 2 times 5. So I'm just multiplying the 2 exponents. I'm multiplying the inside exponent by the outside exponent. Sorry, just a little adjustment here. And what is negative 2 times positive 5? Well, positive 2 times positive 5 is 10. So negative 2 times positive 5 is negative 10. And again, I hope you're a little uneasy here. Notice I haven't put a box around my answers because that negative exponent just makes me a little uneasy. All right, moving on to number 3. Now, I purposely put in 2 kind of different looking quotients. This one's obviously got a lot going on, but I started with this one. So I just gave it to you. It's a quotient of powers. I mean, I hope you understood that. Look, it's a quotient, it has a fraction bar. So this is a quotient of powers. Now, if you remember from yesterday, or not yesterday, the last video, I should say, in a quotient of powers, you end up, after you expand each power, you end up creating these like big ones. So the rule here, or the trick, or whatever you want to call it, the property states you subtract in a quotient of powers. Now, here's where it's a little bit different than what you might have been taught before. I always say, which does the numerator or denominator have more x's or more bases, right? So I'm looking here, there are, and pardon me for being, for like saying this potentially wrong, but there are 7 x's in the numerator and there are negative 3 x's in the denominator. Which one is the larger number? I hope you all said 7, right? Like, please. So 7 is greater, or I won't say larger, I'll say greater. 7 is greater than negative 3, which means there are more x's in the numerator than there are in the denominator, okay? Does that make sense? So when we subtract, we're going to take the greater number and subtract the smaller number, and we know our answer is going to be in the numerator because there are more x's in the numerator. So in this case, what's going to be left in our denominator? Our denominator is just going to be left with 1. So I have in 2 steps, let's say first step here, I have x to the 7 minus negative 3, and then just over 1. And I'm putting in that placeholder 1 just as to emphasize that there are more x's in the numerator, which means our final answer will be in the numerator. Now, what does 7 minus negative 3 actually mean? Just like 4 plus negative 6 means subtraction, subtracting a negative is equivalent to adding a positive. So really this is x to the 7 plus 3, again in the numerator. And then when we finally simplify, we can take out the placeholder 1 because it's not necessary anymore. What's 7 plus 3? That's x to the 10th. Now, I feel better about this example. I don't know about you. I feel better about this example. Why? Because my answer has a positive exponent. So I don't know. I feel better about that. I like the positives. I don't like the negatives. But for now, we'll leave it until the end of the video. Okay, number 4. Now this one is our challenge problem. For number 4, this is a blend of 2 properties. The first thing I notice is that the entire expression is a quotient, but the numerator is a product. So that tells me this is both a product and a quotient of powers. Now, which one are we going to do first? Well, the entire expression is a quotient, meaning the quotient is probably what I'm going to do last. If you remember, whatever the expression is, however we would classify it, that's the math we would do last. If it's a quotient, we divide last. If it's a product, we multiply last. If it's a power, we apply the power last. So because this is a quotient, that means I'm going to simplify the product first, then do the quotient. So in a product of powers, just like over here, what is the rule with the exponents? I'm just going to add them together. Now, I'm not going to change the structure of this expression. It's going to remain a quotient. Now, what is negative 3 plus negative 4? That would be negative 7. So my first step here is I just applied the product property, and now I have x to the negative 7 over x to the 5th, okay? So all I've done is I've simplified the numerator of the quotient, applying the product of powers property. Is this fully simplified? No, because remember, simplify means, right, is a single power. This has two different powers in it. So now we're going to apply the quotient property. Here's the thing. Which does the numerator or denominator have more x's? So we have negative 7 x's in the numerator and 5 x's in the denominator. Which one is the greater number, 5 or negative 7? I feel like 5 is the greater number. Wouldn't you say? I mean, like, right? So 5 is the greater number, which means my answer is going to end with x's in the denominator, right? Because there's more down here. It's a greater number of x's than up here. So we're going to subtract the greater, or excuse me, we're going to subtract the lesser from the greater. So in the denominator here, we're doing x to the 5 minus negative 7. Okay, do you see how that's different from this example? Here we had a greater number of x's in the numerator, so we put our answer in the numerator. Here we have a greater number of x's in the denominator, so our x's go in the denominator. Now, what is subtracting a negative equivalent to? It's equivalent to adding a positive. So again, 1 in the numerator because there's not enough x's there. And in the denominator, we're doing x to the 5 plus 7. And what's 5 plus 7? That's 1 over x to the 12th. Okay, now I feel better about these two because the answer has a positive power, but these two, I don't know. I don't feel super, confident about those. So we'll come back to those. Now here's the point. It doesn't matter if you have negative exponents or positive exponents. The properties work the way that they're supposed to. If it's a product of powers, we add the exponent. If it's a power of powers, we multiply the exponents. Quotient of powers, you subtract greater minus lesser, but you keep track of where are there more. If there are more in the numerator, your answer will be in the numerator. If there are more in the denominator, your answer will be in the denominator. All right, we're gonna move into our notes. So for today's notes, all you need to do is, again, take a piece of paper and you're going to divide it into 2. So you're gonna make a T-chart, kind of like we did in our other ones, okay? So take a piece of paper, divide it in half, and then put a T across the top, just like this, okay? Piece of paper, T-chart. Similar to what we were doing in our last video, we're going to compare some equivalent expressions. So here's the deal. We're going to compare expressions that have negative exponents, EXP stands for exponent, to positive exponents. For the sake of making this video reasonable in terms of length, I'm not going to go into all of the intricate details as to why we can do this with negative exponents. I will record a separate video and send that out for those of you who are like dying to know why, okay? Because I just don't want to make this video too long. So here's the deal. When you're simplifying properties of exponents or powers or whatever, and you're applying the product property and you're applying the quotient property and the power property, you want your answer to be a single power, which means you've done the subtracting, the adding, the multiplying. You've got it down to a single base with a single power, or 2 bases with 2 powers if they're different bases. But the other rule, because if math wasn't complicated enough, is that exponent has to be positive. So if you remember our warm-up, in example 1 and example 2, our answers have negative exponents. That wouldn't be considered acceptable. But our examples in 3 and 4 are okay because they have positive exponents. So yes, this is a single power, but because of that negative exponent, we're technically not done in our work. So we're going to come back to those. So here's all you have to know, okay? I'm going to keep this very straightforward. We're going to go through a bunch of examples, but here's what you have to know. When you have an expression with a negative exponent, okay? So let's take, for example, we'll start with numbers. So this will be example 1. Let's take, for example, 2 to the power of -3, okay? So it's a single power. It has one base raised to a single power, but that power, that exponent is negative, which is like a huge no-no, okay? Here's what we do. A negative exponent is telling you to do something to the base. So like imagine the negative exponent being like, hey, I'm negative. Here's how you turn me positive. To turn this positive, you take the reciprocal of the base. That's a word we haven't heard in a while. So what we're going to do is we're going to take the reciprocal. Now, reciprocal means we're going to flip it, right? Wherever it was, if it was in the numerator, guess where it belongs now? In the denominator. If it was in the denominator, guess where it belongs now? In the numerator. So this 2 to the -3rd power, is this in the numerator or denominator? Well, there's no fraction bar, so that means this is currently in the numerator. So where are we going to flip it to? We're going to flip it into the denominator, which means this is what it looks like. Bear with me here. We now have 1 in the numerator, and guess what's in the denominator? Our base of 2 to the power of +3. Think of this as like you're waving a magic wand. As soon as you put it into the denominator, you flip it and you put it into the reciprocal, the exponent is now positive. Now, again, I hope you're looking at me like, nah, I don't really know if I believe her. Well, there's a reason why we started with 2. Grab your calculators, right? Let's try plugging in 2 to the -3rd power on your calculator. So if I go 2 to the -3rd, the answer that it gives me is 0.125. Notice that it was a decimal, 0.125. I'm going to write that in there, 0.125. Okay, now over on the right side, we're going to do the same thing with our calculator. We're going to do 1 divided by 2 to the 3rd power, and we're going to see if it's the same. 1 divided by 2 to the 3rd power, 0.125. What? Yeah, they're equivalent. Why are they equivalent? Because I didn't change the value of it. I just changed its appearance. So when you have a negative exponent, you take the reciprocal of the base. Kind of cool, right? Let's practice a few more. So let's say, let's put in a little divider here. Let's try a kind of different example. And again, we'll stick with integer bases so that we can use calculators to check our work. Let's say, what if you had a negative exponent in the denominator? So like, what if it looks like this? 1 over 4 to the -2 power. Like, what if that's what it looks like? You know what I mean? Well, is this an acceptable answer? Can we accept 1 over 4 to the -2 power as an answer? No. Why? Because it has a negative exponent. So remember, like negative exponents are no-nos. They are not acceptable for our final answer. So how do we change it into a positive exponent? We take the reciprocal. What's reciprocal mean? Reciprocal basically means we're going to flip it. So where is 4 to the -2 power? Notice how it's in the denominator this time. So when we flip it, where does it end up? It ends up in the numerator, right? So now 4, our power's in the numerator. So I'm going to do this in 2 steps. Basically, we flipped it, right? 1 is now in the denominator where it used to be in the numerator. And then once we flip it, is this still negative? No, you waved that magic wand. This is no longer negative. This is now a positive exponent, which is just 4 to the power of 2. Right? Because we don't need that placeholder 1. And in fact, you don't even need to do this step if you don't want to. You could just put it up in the numerator and call it a day. So let's see. Let's check using our calculator, right? Because you shouldn't just believe me blindly. First of all, please don't use a calculator for 4 to the 2 second power. Like, you should know what that is. 4 to the second power is 4 times 4. What is 4 times 4? 16, right? Okay, so we know this is 16, okay? The question is this 16? Doesn't look like it should be, right? It looks like your answer should be a fraction or a decimal, but here we go. In our calculator, we're gonna do 1 divided by 4 to the power of -2. What do you see there? I see 16. Yes, because these are equivalent. They both have values of 16. I know, it's totally crazy. Like, what? Why does that actually work? I will show you in a separate video why it works and why we take the reciprocal and why all of this happens. But I'm not going to do that in this video because otherwise it'll be too long. Okay, let's look at one more example. Okay, and this one we'll do with variables. And I'm going to just make it a little bit more challenging because I don't want to lose you. So here we go. Last example. Let's say we have m to the power of -3 over y to the power of -7. Okay, I like this example, I just realized. Okay, here's the deal. Is this a quotient of powers? Meaning, can I subtract exponents here? Like, can I do -7 minus -3, blah, blah, blah. Can I do that? No. Why is this not a quotient of powers? Because in a quotient of powers, you have to have the same base. Is m the same as y? Not the last time I checked. Nope, right? Like, definitely not. So this is not a quotient of powers. I know it's weird. It is a quotient and it has powers in it, but you can't apply a property here. Like, I can't do -7 divided or minus -3 or -3 minus -7 because these are different bases. You with me? Now, let's say I did all of this work and this is the answer that I got. Would this be considered acceptable? We would consider this a single power because each base is raised to its own exponent. In other words, there's only one power with m and one power with y. But it has negative exponents, which is a huge no-no. So what we're going to do is we're going to wave our magic wand. We're going to take the reciprocal. What's reciprocal mean? You got it. We're going to flip it. Okay, and then once we do that, our exponents become positive. Yay, we like positive exponents, right? Now, here's the thing. When we flip this, we have to flip both of them because both of them have negative exponents. And we'll look at some more examples later on, not in this video, where you wouldn't necessarily flip both. You would only flip one or the other. But because they both have negative exponents, we're going to, in order to make this a +3, it has to end up in the denominator. And in order to make this y to the +7, it's got to move up into the numerator. So here we go. Ready? So we're going to flip it. M is going to go from the numerator down to the denominator. Y is going to go from the denominator up to the numerator. So now y is in the numerator. M is in the denominator. And then what happens to the exponents? They become positive. They take the exponent with them. There's still 3 m's here, and there's still 7 y's here. But in order to make it positive, it moves up. So now this is y to the 7th, m to the 3rd. Is that considered a single power? Yes, it is, because each base is only there once and both exponents are positive. Now, unfortunately, we can't check that with a calculator. I mean, you could plug in numbers and check it on your own. That would be totally fine. Make sure that if you do that, you choose different numbers for m and y. You wouldn't want to choose the same number. All right, so guess what? That leads us to a rule. So the rule is, or a property, when you have a negative exponent, if you have a negative exponent, which is a big no-no, we don't like negative exponents, right? To turn it positive, what do? We take the reciprocal of the base. Okay, so what does that look like? Well, if we have something like x to the negative a, right? No, we don't want that negative exponent. This is currently in the numerator, so we would put it in the denominator. That would be 1 over x to the positive a. So it just flips. Since it's in the numerator, it flips to the denominator. Or if we have it already in the denominator, like 1 over x to the negative a, and a is just a placeholder for a number, like put a number in there, -2, -6, -7, -1 million, right? We take the reciprocal because it's in the denominator. Where does it go? Up to the numerator. That's our new rule. So what are we going to do next? Woo, as I almost fell over. What we're going to do next is we're going to go back to our warm-up. We're going to fix, or at least not fix, but finish problems 1 and 2, because those had negative exponents. Negatives are no-nos. And then we're going to wrap up with 4 more examples in an exit ticket. So go ahead and go back to your warm-up. Here we are. Let's go back to our warm-up and let's just finish the work that we didn't think was right the first time around, right? Like there's some of these that we were looking at that were like, I don't like that, you know what I mean? So we're looking for negative exponents because the negatives are no-nos. So in the first one, we applied the product of powers, we added them up, and our answer was x to the -2. No, right? So how do, we have it right up here. Look at that, I kept it up there. How do we deal with that negative exponent? How do we change it into a positive? We take the reciprocal. So it's currently in the numerator. How do I know that? Because there's no fraction above it, right? If it was in the denominator, it would look something like this. It would have a fraction in it. So what we're going to do is we're just going to take the reciprocal, which means our x that was in the numerator ends up in the denominator. And after we do that, what happens to that exponent? Is it still negative? It's now become positive. That's our final answer. And these are equivalent. If you don't believe me, take a number. Let's say x is 5, right? Let's say x is 5. Take your calculator, right? And go 5 to the power of -2. Oops, yeah. And guess what I got? I got 0.04. Okay, so that's 5 to the power of -2. Now do 1 divided by 5 to the positive power of 2, and you get the same thing. That's because these are equivalent. A negative exponent is equivalent to a positive exponent in the reciprocal. I know, it's totally crazy, right? Okay, so this is now good. It's a single power. It has a positive exponent. We feel good about that. What about this one? I don't really feel good about that one. Why? I mean, it is a single power. We did apply the property, but that exponent is negative, and negatives are no-nos. So how do we make it positive? It's going to do the reciprocal. How do I know it's going to end up in the denominator? Because it's currently in the numerator. So when I flip it, that x is now in the denominator. And is this still to the power of -10? This is now to the power of +10. Okay, and again, if you don't believe me, pick a number for x. Let's say x is 2, right? Go ahead and type in 2 to the power of -10. Oh, look at that. That is a long number, 97656. Okay, right? Big number. Let's see if we get the same thing with the second expression. So 1 divided by 2 to the power of 10. I don't know about you, but I think that's the same number, right? These are equivalent. And if you want to check your work, that's the best way to do it. Like plug in numbers for x and type them into a calculator, or you can do a Google calculator, or you can use Desmos, whatever, right? All right, let's look back at number 3. Now, number 3 was good. Our answer was a +10, but I'm going to show you, and the same thing over here with 4. I'm going to show you how you could also do these with negatives in a little bit. So this is already a +10. It's a single power. My exponent's positive. We're good. That's actually the correct answer all along. Done. Over here, same thing. I have a single power. My exponent is positive, and we're good. So now what we're going to do is we're going to do an exit ticket. So you're going to take another piece of paper or another section of your notes and divide it into 4 again. And this time we're going to do the entire process. So applying the property and making sure that my exponent is negative in the end. So go ahead, set up your paper just like this. Now, there's a reason why I left a little bit more space in the bottom two than the top two, because the top two are going to be more straightforward. The bottom two are going to be a little bit more challenging, because I could tell in your worksheet practice from the last video, or your practice sheets for those of you in my class watching this, that you struggled with some of the ones that combined properties. So we're going to do 2 straightforward ones and then 2 challenge ones. So go ahead, number your paper again. In fact, because this is the exit ticket, to separate it from the warm-up, we'll continue the numbering. We'll call this number 5, number 6, number 7, and number 8. Okay, same thing as our warm-up. We're going to apply the property. So if it's a power of powers, we multiply, product of powers add, quotient of powers subtract. And then we're going to double check and make sure that our final answer, our final single power, has a positive exponent. So here we go. So for number 5, let's do x to the negative 7th times x to the negative 4th times x to the 3rd. Ooh, yeah, I just kind of kept going there, right? Whatever. X to the negative 7 times x to the negative 4 times x to the 3rd. That's number 5. Number 6 is going to be x to the 3rd to the power of negative 2 times x. Okay, I did kind of blend 2 together there, but that one won't actually be that difficult. It's actually pretty straightforward. Okay, 7 and 8, we're going to do some quotients because those are a little bit more tough. And then number 8 is going to be real fun. Okay, number 7. Let's go ahead and do x to the negative 5th to the 2nd over x to the negative 8th. Ooh, that's going to be fun. I'm excited. Okay. Anyways, I'm cracking myself up. All right. And then number 8, we're going to make a little bit weirder. Okay. Let's see for this one. Let's go x to the negative 10th times y squared. What's that y doing in there? Over divided by x to the 2nd times y to the negative 3rd. Yeah, I like that. It's going to get crazy, and that's what I love about it. Okay, cracking myself up on a Wednesday morning. Okay, so first of all, don't be alarmed by those negatives. Deal with them at the end. Like, do all of the properties like you normally would, and then deal with the negatives at the end. Like, they're not going anywhere, right? That's my advice for you. Now, some teachers might give you different advice. That's just my advice. Take it or leave it. Okay, let's first identify the property that we're going to use here. Number 5, is this a product, a quotient, or a power? I think this is a product. So I'm just going to put PR for product, right? That's a product of powers. So I'll write out product, otherwise that's going to sound confusing. So this is a product of powers. What is the rule in a product of powers? Well, because all of these have the same base, and that's important, because if they don't have the same base, you can't continue that multiplication. Because all of these have the same base, that means that we're just going to add the exponents, okay? So we're going to add up these exponents. So that means, let me use a slightly different color here. We're adding negative 7 to negative 4 to positive 3. So that would look like this: x to the negative 7 plus negative 4 plus 3. Okay, we're just adding up those exponents. Okay, so what is negative 7 plus negative 4? Negative 7 plus negative 4 is negative 11. And negative 11 plus 3 is negative 8. Do I believe that? Yes. So this is x to the negative 8. All right, we're done, right? No, we're not done. What's a no-no here? Negatives are no-nos, right? That negative 8, we don't like that. So let's apply what we learned. How do we go from negative to positive? We take the reciprocal. So this is currently in the numerator. How do I know? Because there's no 1 above it, right? There's no fraction bar. So what we're going to do is we're going to wave our magic wand, and put that x in the denominator. What's left in the numerator? Just a placeholder, 1. And is this still a -8? No, it becomes a +8. Okay, now again, if you don't believe me, that's totally fine. Plug in a number for x. Try like 2. Start with this, 2 to the -7 times 2 to the -4 times 2 to the 8, or to the 3rd. Like, put that all in a calculator, get a number. Then check it with this, take 2 to the -8, put it in a put it in a calculator. And then do 1 divided by x to the 8th, put it in a calculator. All 3 should be the same number, right? That's how you can check with a variable. Or you can just believe me that it's correct. All right, number 6. This one is a little bit tougher because this one also blends 2 different properties. I see a power of powers, but I also see a product of powers. So this is a power and a product of powers. Which one are we going to do first? Well, notice that this product is outside of the parentheses, which means I need to simplify this power before I can do the product. In other words, the entire expression is a product. Like, this is its own factor, which means we're going to multiply last, or we're going to multiply those 2 bases together last. So the first thing I need to do is I need to simplify this power of a power. How do I do that? You multiply the exponents. So this would be x to the 3 times -2. And then I'm bringing along the x so that I don't lose it, right? Sometimes we lose our work halfway through. Okay, what is 3 times -2? 3 times -2 is 6. Excuse me, -6. So this is x to the -6 times x, right? Well, now that the power is gone, I'm looking at this as a product of powers. And what's the rule in product of powers? We add the exponent. But hold on, there's an exponent missing here. Do you see an exponent on this x? I don't. Does that mean that we don't add anything? No, there's a hidden exponent there. It's a hidden 1, right? There's just one factor of x. So now I'm going to add these together. So that would be x to the -6 plus 1, right? What's -6 plus 1? -6 plus 1 is -5. I'm trying to get you to see that. So this is x to the -5. So what I've done here, just review, there's a lot of x's up there, right? If you look, the first thing we did is we applied the power of powers property, right? We dealt with the power. We put that as x to the -6. Then we did the product of powers, right? Now we've got it down to x to the -5. So this is technically a single power, right? We've gotten rid of all the other factors. We've done all the math that we can, but there's something wrong with it. What's wrong with it? It's got a negative exponent. So let's wave our magic wand. It's in the numerator. How do I know? Because there's no 1 above it. There's no fraction bar. Let's go ahead and move that into the denominator for our final answer. So our final answer is a positive power is 1 over x to the power of +5. There you go. Now, again, it did require quite a bit, but like I'm just using the properties as I see them. Power of powers, product of powers, right? Take it one step at a time, one property at a time. All right, we've got 2 more and then this video will be over. Let's take a look at number 7. So what do you see? I see a quotient, obviously, but what's in that numerator? There's a power of powers in the numerator. So I see a power of powers and a quotient of powers. We're just going to leave it like that because I'm going to use this space. Okay, so what do we do first? Well, the entire expression is a quotient, which means that's what we're going to do last. So we have to deal with this power first. Let's simplify the numerator. Then we'll be able to simplify the entire quotient. So here we go. How do you simplify a power of powers? Just like we did over here, you're going to multiply these exponents. So we're going to do this in a series of steps. So now in the numerator, we're going to multiply x to the power of -5 times 2. And guess what? That x to the -8, it's still there, right? It doesn't go away. So that leaves us with x to the -10th divided by x to the -8, okay? here's where it gets a little weird, as if it wasn't already weird. We have options, okay? We could technically continue this in 3 different ways, but really I'll show you the 2 different ways that you could do this, okay? The first way is just how we did the warm-up. Remember, when you're doing quotient of powers, you do subtraction. You take the greater exponent and you subtract the lesser exponent from it. I mean, frankly, it doesn't matter how you subtract as long as you keep it in order. Which number is greater? Is negative 10 greater or is negative 8 greater? Negative 8 is greater, guys, right? Like it's the greater number, not the larger number. You got to think about it in terms of on a number line. So that means there's technically more x's or a greater number of x's in the denominator, okay? We're looking at the greater number, not the larger number. So you might like option 2 if that didn't make sense to you, got it? So this is option 1 for simplifying, okay? And if you don't like option 1, I'll show you option 2. Basically, that means that we're gonna have our answer in the denominator. Why? Because there's a greater number of x's, not larger. Negative 8 is greater than negative 10. So then we subtract negative 8 minus negative 10, right? You take the greater one minus the lesser one. Well, subtracting a negative is equivalent to adding. So this is the same. I'm just going to erase and rewrite it, considering I'm running out of space. This is the same as adding 10. What's negative 8 plus 10? Negative 8 plus 10 is 2. So my answer is 1 divided by x to the 2nd power. So again, I took the greater number, subtracted the lesser number, and because this is greater, that means there are technically more x's in the denominator. I ended up with 1 over x to the power of 2. Now, as I said, there's actually another way to do this that might make more sense to you, okay? If, for example, you're like, ooh, I don't really like doing the negative 8, like, that doesn't make sense to me. Let's say instead of using the greater number, you use the larger number. I use x to the negative 10 instead. So let me show you what happens there. Let's say you're like, nope, there are more x's in the numerator because 10 is bigger than 8. That's okay, as long as you keep in mind that you're gonna have to do greater or larger minus smaller. And since there's more in the numerator now, if you look at it like that, like if you look at it in terms of larger, then your answer is going to be in the numerator. So this would be in the numerator. So there's a placeholder 1 in the denominator. Negative 10 minus negative 8. Okay. So I'm just doing it in reverse. You might be like, why is she doing that? I'll show you. So let's say you did negative 10 minus negative 8 instead of negative 8 minus negative 10. Well, negative 10 minus negative 8 is equivalent to negative 10 plus 8. If subtracting a negative is equivalent to adding a positive, right? Let me rewrite that so it's a little bit clearer. So this is negative 10 plus 8, okay? Again, in the numerator, because you decided that there are more x's in the numerator. What is negative 10 plus 8? Negative 10 plus 8 is negative 2. So now your answer is x to the negative 2 power, which is in the numerator, right? But can we accept that as our final answer? No. So what would we have to do to it? We would have to take the reciprocal of the base. And guess what your final answer would be after you take the reciprocal of the base? It would be 1 over x to the 2nd power. I know, it's crazy, right? Like, what? So let me make my point here, because that could have been a little bit confusing. The idea is when you're applying the quotient of powers property, you can either subtract numerator by denominator and keep it in the numerator, or you can do denominator minus numerator and keep it in the denominator. So it actually doesn't matter as long as the one that you're subtracting, right, whichever one is larger, whichever one is happening first, stays where it belongs. So when I did negative 10 minus negative 8, I stayed in the numerator. Negative 10 was my first number, my larger number. When I did negative 8 minus negative 10, I kept it in the denominator because negative 8 was my first number. All right, we have our last one here, okay? Last one, and then that'll be it for this video. Number 8, I purposely put in some negatives, some x's, some y's. Right now, what properties do you see? You might think this is a product of powers, but I can't do anything with an x and a y. like 10 x's and 2 y's I can't combine those, right? I can't say that there's 12 x's or 12 y's. So this is actually not a product of powers because these are different bases, but it is a quotient of powers. So we're just going to be applying the quotient of powers property. Okay, so how do we do that? Well, the way that we do that is just like we were doing over here, right? Quotient of powers means you subtract, and then you just look at are there more in the numerator or the denominator? That's all it is. Like, which one has more? And again, technically it doesn't matter. You could do it either way. Like, I could keep the x's in the numerator, I could keep the y's in the denominator, but I always like to say which one has more. Which one has more? So let's look at this. Let's start with the x's. Like, just take it one step at a time. We have negative 10 x's in the numerator and positive 2 x's in the denominator. Which one is technically more or greater? Last time I checked, 2 is greater than negative 10, right? So that means my answer is in the denominator because that's the greater number. You could also do it in the numerator with negative 10, but just trust me. So my x's are going to stay in the denominator because there are more. 2 is greater than negative 10. So that means we're going to subtract 2 minus negative 10. Notice it's not 2 minus positive 10. This is a negative, so we're doing 2 minus negative 10. And why is it in the denominator? Because that's where the greater number of x's are. If there's 2 here, there's negative 10 here, this is greater. For the y's, same thing. Which one has the greater number? Well, we have 2 in the numerator, negative 3 in the denominator. Last time I checked, 2 is greater than negative 3. That means my y's are going to stay in the numerator. Why? Because there's a greater number in the numerator. So in the numerator, we have y, and then we're going to subtract 2 minus negative 3. Why are we doing it in that way? Because 2 is the greater number. 2 minus negative 3. Now this looks really messy, but here's the cool thing. Our answer is 1 step away. I know, crazy, right? What is subtracting a negative equivalent to? That's equivalent to just addition, isn't it? Last time I checked. So our final answer, what's 2 plus 3? 5. We have y to the 5th power in the numerator. What's 2 plus 10? 12. X to the 12th in the denominator. And guess what? All positive exponents. Is that crazy? Like, this was done in 2 steps. 1, 2. Nutso, right? All right. So in summary, when you are dealing with negative exponents, my advice is apply the properties first. So add them up, multiply them, subtract them, right? When you're subtracting, just keep in mind what you're subtracting from. The larger one that you're subtracting should be where it started. Like, if it's in the numerator, keep it in the numerator. If it's in the denominator, keep it in the denominator, right? Apply the property first, deal with the negative at the end. That's my suggestion for you. All right, so that is the end of this video. I will record a second video that explains why we take the reciprocal of the base when we have a negative exponent, in case you were just wondering. All right, have a wonderful rest of your day and have fun simplifying powers.